Saxon Algebra 1, Lesson 51. You guys, I lied at the end of the last lesson. I said that we were done with Lesson 51. No, we were done with Lesson 50. I was just getting excited and thinking ahead to Lesson 51. So, excuse me for lying to you. Let's dive in. This is fun. This is something we're going to build on a ton. Do not let your brain make this harder than it is. Okay? Sometimes students just go, oh, it's weird, it's different, it's really must be hard. That's not true. Okay, we're supposed to graph this. How in the heck are we going to graph that? We know how to graph ordered pairs, right? If things are written like this, we know how to graph that. That's easy, right? But we don't know how to graph this. So what we're going to do is we're going to use this to create some ordered pairs because we know how to graph them. And later we're going to take a shortcut that will eliminate a lot of this drama that I'm going to teach you how to do right now. But for now, this is the easiest way to understand how we do it. What we're going to do is we're going to make a little chart. What will always be the same is we're going to put an X there and we're going to put a Y there. And then this equation that we're trying to graph, we're going to put that in here. Y equals 2x minus 1. Okay, so that's how we set it up. Always x here, always y there, and then the thing that we're trying to graph, this line, this is going to be a line. It looks like an equation now. We write that in here. Now, what we're going to do is we're going to choose some random, some random values for x, and we're going to calculate, okay, if this is x, then this is what y would be, and then we'll write the y over here. Here's the thing, students get freaked out, and I remember being freaked out about this. How do you know what to choose? Well, make it as simple as possible. I like to choose 0 as one of mine because 0 is a super easy number to work with, right? So now what we do is we write it in here. And what I'm going to do is I'm going to ignore the y equals part, and I'm just going to do 2, and I'm going to plug in the 0 minus 1. This is just like those problems we've done where it says evaluate 2x minus 1 if x equals 0. That's exactly what John was preparing us to do, is make this chart. So now I've got 2, and then I've got 0 in for x, minus 1. Now I can do the multiplication. 2 times 0 is 0 minus 1, and that would be minus 1. Okay? So going from here, picking this number seems kind of weird, but you can just pick easy numbers. I'll show you what else I'm going to do in just a minute. And then we plug it in and run the number through just like we've done in other problems. Now look what I've got. I've got an ordered pair. 0 minus 1. I know how to graph that. And in a minute, that's what I'm going to do. So what I'm doing is I'm taking this information about a line and I'm converting it to ordered pairs. Now, this is going to turn into a line. Spoilers, I told you that in the very beginning. In order to draw a line, we're going to need 3 points. 3 points is the best way to draw a line. If you only draw 2 and you make a mistake, you'll never know it. But if you draw 3 points, they better line up, and if they don't, you know you made a mistake. So we always do 3 points. Now, I chose 0 because it's a really easy number. Now I'm going to choose 1. Another easy number. So I'm going to say x equals 1, and I'm going to plug it in right here. 2 times 1 minus 1, right? I'm just using this. All right, I multiply, and that becomes 2 minus 1. So my y value, when x is 1, y is also equal 1. So I'm going to write that here, okay? Now, I want to choose a negative value, just to make it fun. I could choose -1, but just to be crazy, I'm going to choose -2. You guys, there is no magic to this. Just choose simple, easy numbers. I like to choose 0, a positive number, a negative number. All right? No big deal. So it's going to be 2 on the outside, right? And then x equals -2 minus 1. 2 times -2 is minus 4 minus 1. So that means my y value will be -5. So the third point I'm going to graph is -5. And this is a great illustration of why we want to keep these numbers simple and small. As these numbers get bigger, these numbers usually get bigger. And we don't want big numbers. We just want cute little numbers. But this is fine. I can graph this. So I'm going to draw now my graph over here. What I usually do, you guys, is I use the blue lines in the paper for the y-axis. And then I try to make lines the same distance apart for the x. If you would like to use for real graph paper, by all means, ask your mom to grab you some at Target or Rite Aid or whatever. It's pretty readily available. But just draw in some hashies. Don't worry about the numbers. And now let's start graphing. 0, -1. Okay, this is 0. And then we want y equals -1, so that's down. So there's the first point. Okay? I'm not going to put the names on these. I'll show you how I'm going to name this in the end. Our second point is 1, 1. So there's 1 and there's 1. And then -2 is here, and then -5. 1, 1, 2, 3, 4, 5. So I have to extend a little bit. See how I did that? And here it kind of helps if I make my rectangle, right? Now I can see very clearly, oh look, there's a straight line. And I'm grabbing my little notebook that I keep handy, and I'm gonna use that instead of a ruler because I don't have a ruler handy, but I wanna use a straight edge to draw a straight line. So I'm kind of lining those up as best I can. And there is the line. This line represents all the points of x and y that will be true for this equation. We figured out 3 of them, and that gave us a good idea, but this line represents all the values of x and y that will make that come true. So the name of this line is y equals 2x minus 1. And that is the solution of our problem. Sweet, right? And we got it right. All right, so that is how we graph a line that's given to us as an equation. We turn it into 3 points in the XY format. Later, we're gonna do something that's even easier. Okay, so let's do it again. Right? Graph y equals 1/2 x plus 2. Okay, you notice there's a fraction in there. That's a little annoying, right? But that's okay. I'm going to show you a trick to deal with it so we don't have fractions in our answers. I'm going to draw the chart. Now, I want to tell you something so you know. John draws his charts differently than me. I don't like how he draws his charts. Mine are better, so just don't even. This is x, this is y. When we write it in here, actually, we don't have to write that part. Just write this part. 1/2 x plus 2. Now, as I look at this, I start to think about what values I should choose. And I tell myself, I have to multiply whatever I choose times 1/2. I don't want any fractions here. I don't want to have to add 2 to a fraction. So what I want to do is I want to choose values for x that are going to make that fraction go away. So let me show you what I mean by that. First, I'll choose 0, because look what happens. When I multiply 1/2 times 0, it's going to go away, right? So this will become 0, and then when we add the 2, oh, that's a cute little point, right? In the beginning, I like to rewrite the ordered pair right there so you can see it, but later you'll just be able to work off the chart. You don't have to rewrite it here. You'll just say, oh, 0 and 2, right, and graph that way. Now, I don't want to choose 1 for my next value, because if I choose 1, it would end up being 1/2 plus 2. No. What I'd rather do is choose 2, because look what happens. When we multiply 1/2 times 2, this will reduce to 1, right? Because this is like 2 over 1, so I multiply through. I get 2 over 2, that's equal to 1. So this will be 1 plus 2, 3. Ah, that looks like a good one to graph. Okay? And because that went so well, because it cancels with that denominator, I'm going to choose -2 for my last point. A negative number. I like to choose a positive and a negative, and I chose one that I know is going to be clean with my fractions rather. I don't want to have any fractions I'm trying to graph. That's gross. Now when I multiply -2 times 1/2, I will get -1 plus 2, and that will give me +1. All the work we're doing in this chart is just like these evaluation problems we've done for a long time. The only trick is that we're choosing the variables for x ourselves. Before, John used to tell us what to plug in. We're choosing ourselves, and we're just trying to be clever. We're trying to keep these numbers small, right in the middle of the graph, so we don't have to draw some giant graph up to 14. We want to keep the numbers small, and it's a good idea to choose a positive and a negative value as well as a 0, and we always want to have 3. This time I'm just going to draw my graph over here. I'm going to squeeze it in. See, I chose nice numbers, so they're going to be nice and small. A small graph should help. This one's a little messy. If your graph is a little messy, it's not the end of the world, but it's going to be harder to get your line rather, to look like the solution. So I always recommend being as neat as you can. And this one's not very neat, so forgive me. Okay, 0, 2. 0, 2. Remember, this is always x and y. 2 and 3. And then -2 and 1. Aha! So this one kind of goes through like this. Okay? Beautiful. All right. When I look at the solution, I see that I copied the problem differently. John actually put a negative sign there. It just changes the way we would do our calculations, and the line it would look a little different, but this is correct for this equation. And we say that the name of this line is y equals 1/2 x plus 2. And this is correct for what we have. Again, the book looks different because I copied the formula wrong. So that's okay, we're good. All right, and there's one more of these. And then we're gonna look at some crazy exceptions. This one is y equals -x. All right, that's pretty straightforward. Let's see what happens. We have x, and then we can just put -x here, right? We can write y equals if we want. It just is a little more crowded, and you don't really need to show this here. So I just write this part, and then y. So if x is 0, then our calculation is -0. Oh, that's just the same as 0. Okay, that's pretty easy to graph. What if we choose for x 1, then -1 is our y value, right? There's not much of a calculation here. That's why it looks exactly the same. Here I used this middle space to calculate, but here there's really not much to do. And then let's make this one -1. That would become -1. That becomes +1. Huh, interesting, right? Notice we've done all that work before, so none of that is new. I'm going to try to be neater this time. X and Y, arrowheads and letters, yes. Hash marks, you don't have to number them all. And then try to make it even. This x-axis is awfully wonky, isn't it? Okay, and then we write these as ordered pairs. I'll do that again, but you don't have to actually write this out as a separate step. I could just look at these and go, okay, the first point is 0, 0. 0, 0. +1, -1. Oh, we haven't had any that we graph like that. -1, +1. Okay, so this line goes like so. And the name of that line is y equals -x. And every single point on this line, every single pair of x and y coordinates that fall on this line will be true for that equation. Okay, now we're going to do, I guess, 3 more. They're similar though. that are kind of special case problems. First, we're going to talk about horizontal lines. Well, I'll just put them together. Horizontal and vertical lines. Notice that all of these lines were tipped, right? None of them were perfectly straight in either direction. Now we're going to deal with that scenario. And they're not harder, they just look a little weirder. The equations look weird. X equals minus 2. That's our first one. Well, how are we going to make a table like that when there's nothing to calculate or plug in? That's the first thought you have. When you have that thought, quickly follow it up with a second thought. Oh, I don't have to. This is a weird one. So what we do in this one is we just let's find the place where x equals negative 2. This is the x-axis. This is the y. X equals negative 2. Okay, we can put in some markers. There's negative 2. What that means is no matter what the y value is, x will always be equal to negative 2. So we can draw the line in just like that. Okay, so this line represents all the solutions of x equals minus 2. Because no matter what point we choose for y can vary, right? But x will always be equal to negative 2. The other weird one is if we have y equals 4. And again, we look at that and go, how can we plug it in and calculate? You're right, we can't. So we recognize, oh yeah, this is another weirdo. X and y. Y equals 4. So I'm going to squeeze a little bit. I'm going to make my marks smaller so that I can fit it in. Y equals 4. So we go to the place where y equals 4. And this time, we want to draw the line this way because what we're saying is no matter what x is down here, it's changing. Y is always equal to 4, okay? So when we just have a plain x, that gives us a vertical line. And when we just have a plain y, that gives us a horizontal. Here's the good news. You don't have to memorize that. When you find an equation that you're being asked to graph and it looks weird, just recognize, oh, it's going to be either horizontal or vertical. All I have to do is think logically and I'll figure it out. Okay? And then for our last problem, we're going to combine these two steps, these two types of lines. Okay, graph y equals 2x and y equals 2 on the same rectangular coordinate system. Okay. Well, this one doesn't look too weird. This one we know we can do with a table like this, right? And we can choose some x values and we can multiply the x values times 2 and that will give us the y values. And we'll do 3 of them. Let's choose 0, 1, and negative 1. And then this one's a weirdo, isn't it? This one just says y equals 2. So we know it's one of those trick situations. You may remember whether it's horizontal or vertical, but we'll pretend we don't know, and then we'll just draw it in. All right, so I'm going to start my grid. This is my x, this is my y. I like you to put that there until it's firmly burned into your brain. Next year we won't have to write that every time, but this year I want you to put arrowheads, x and y, every time you draw the graph. Okay, let's go back to this one. If we choose 0 for x, which I like to do because it's so easy, 2 times 0 equals 0. So our first point is 0, 0. Oh, okay. And we'll graph as we go. I'm not writing these as separate points. I'm just pulling that in my eyeballs to be, oh, that's my ordered pair, 0, 0. That's where that point goes. If I choose 1 for x, which I do because it's so nice and easy, then my y value will be 2. Okay, so I better put in a 1 and a 2. So this is my ordered pair, 1, 2, beautiful. And now if I choose negative 1, which is also easy, but this time I chose a negative number, 2 times minus 1 gives me minus 2. So this time I'm going to do minus 1 and minus 2. There's my third point. Oh, they seem to have lined up quite nicely. So I will draw a line to connect. I do like you to use some sort of straight edge because it's a lot easier to get a clean line. You can just use the edge of your book or whatever you want. Like I said, this is a book I keep lying around. I'm making notes in it for things I have to remember to do, often related to math. So I keep it close by. If you've got something on your desk, you can use the side of your phone. That actually works really well, or a tablet. The side of your math books works well. Make it easy, you guys, but just find something that's straight. Okay, so the name of this line is y equals 2x. These are the points we got from that equation. That's all beautiful. Now let's try this one, y equals 2. This is one of the weirdos. Let's figure it out. This is the y-axis. This is 2. So what it says is that no matter what's happening with x, y will always be equal to 2. So it's this way. And so by drawing them together, later we will have some cool things we can do with those two lines being drawn in. So we did it. This is the correct answer. Yay. All right, that is lesson 51. We are on the road toward graphing. We're gonna do lots of it. You'll get better at it. I hope this was enough to challenge you, but not make you pull your hair out, and also not seem really, really boring. It's the delicate balance we walk, you guys. I always want you to feel like it sounds somewhat familiar, but not the exact same thing you've heard before. So hopefully I did it. All right, that's the end of lesson 51. See you next time.